I'm so pleased to be able to talk with you this morning about my passion, what I've spent my life doing, which is the integration of geospatial technologies and environmental protection. And so I really want to acknowledge the previous speaker about this vision of bringing these two together in a professional setting. You and I live in a very difficult world. We know this. It's scary to me. And everything that we thought about 30 years ago, 40 years ago, and even 50 years ago seems to be coming true. That makes me feel not so good, actually. We are living in a dangerous world, one that would suggest doom and gloom in climate, in biodiversity, in livable cities, in extrapolating population growth, in shortages of natural resources, and this impacting security, and my theory is ultimately the environment. And at the same time, we are living in a time of unprecedented advances in science, in health science, in human science, and in technology. So are these related? I don't know exactly, but I want to talk about the relationship this morning. Fundamentally, our world needs a new approach. Some kind of framework that allows us to, use the popular term, reboot how we are managing the planet. And increasingly, given population's growth, we are given that responsibility to manage our planet. A framework that allows us to both understand our human footprint and the patterns, and also lets us chart or design a new future. Today, not only the traditional geospatial measurements of LiDAR and imagery and mapping are available to us, but all sorts of interesting new social media measurements. Virtually everything is being measured that changes and organized into these information systems that allow us to interrelate and model processes of change. GIS formally allows us to organize these measurements into 6 fundamental knowledge types. The data itself, the surveys, the measurements, and then the data models for semantically organizing these measurements, data and data models. And then third, analytic models, which are used to combine these measurements into models of process, like land use change, or siltation, or forest change, or land use change. And fourth, the way that we represent that knowledge in the form of cartographic or visualization knowledge. Each of these are skills that we have learned over the years in our professions. A fifth type of knowledge is workflows. This is perhaps one of the most important parts, which is about how we integrate this knowledge into human work, how we apply it in land use planning, or in forest management, or in water, or in virtually all activities that humans do. And the 6th category is metadata, which describes the other 5. This is particularly important when we deal with the web and want to share our knowledge. We want to disclose the quality of our knowledge, the models, the measurements, the analytics, and the cartographics, and the authors. These formal categories help us think about what GIS does and how it matters. In the short time, 30 or 40 years since the invention of this technology, I would assert that it has caused change in human thinking. It's changing how we reason, the overlay idea. This is related to that. Subtle to most of us, but on the other hand, very important. It's changed spatial thinking. It's introduced spatial thinking or formalized it. Second, particularly with the web, it's helped us collaborate. You do this, I'll do that on the same place. Places are very important. place-based approaches are very important, where we look holistically at place with lots of disciplines organized around that place. And third, the visual language of GIS has changed the world. I'm over here. It's over there. Here's where the problem is. All of these tenets are providing a kind of foundation or framework for human action. It's very subtly changing society. And the developments of things like Google Earth opened people's eyes to this notion that, oh, spatial relationships, spatial visualization. What a magnificent thing. At the same time, GIS, quantitative geography, or some people call it computational geography, has advanced science. It's not simply observational geography anymore. It's measurement, quantification, analysis, and modeling. This is a revolution in what we see the world described and has how we describe the world, and has opened up the world for new kinds of exploration. Not simply exploration of the polar ice caps or the deep, dark part of Africa or this mystery or that mystery, the highest mountain, which geography always had. No, this is a different kind of exploration. It's the exploration of how this is related with that. The exploration of understanding how the world works and what's happening to it. I would also assert that GIS as a technology is changing how we work. It's connecting the dots, the measurement dots, with the data management dots, with the analytic environment. Those databases are providing the basis for visualizing and analyzing and planning what we should do, decision support. And that quantitative, systematic, holistic, visual environment is helping us make better decisions. You might say the world is still going to hell. Yes, that's true. But at the micro level, at the urban level, at the forest level, and particularly in individual disciplines, I would suggest we're a whole lot better off because we have this framework, science-based framework on which we're building decisions. And we're teaching each other how to use that set of methods. GIS is already widely used in thousands and thousands and thousands of governments here in Germany, here in Europe, and around the world, at all different scales and in all kinds of disciplines, from carbon to forest carbon management, to environmental measurements, to social economic analysis, for picking the right places for public facilities, for transparency of government, and literally dozens and dozens and dozens of other applications. This is creating an enormous amount of new geographic data. So the mission is being satisfied. We're putting out the fire, so to speak. But at the same time, we're building a database that collectively, with little postage stamps of information, are covering the planet in quantitative form. An example of this is in local government, where the modern local government has a central GIS database, shared infrastructure, with lots of departments who use that common infrastructure or update that common infrastructure through transactions. The planning department data is used by public works. The public works transactions are used by police and fire, and so on. A kind of living organism of transactions around a core city. And the same is true in utilities. The same is true in national governments